Hello all. So today we are going to cover the topic application of integration, that is to find the area under a given curve. So first question, find the area of region bounded by ellipse. So as you know, ellipse has a standard equation x square by a square plus y square by b square equal to 1. So we have to find the area bounded by that ellipse. So given ellipse is x square by 16 plus y square by 9 equals to 1. Now in application of integration in such questions, what are the important parts? So we use this integration to find area under a given curve. So first I'll tell you the principle what we do here. Suppose we have any curve, okay, we want to find the area under this curve. We use the method of integration, means what we do is we consider a small strip. Integration means nothing but adding up together, that is integration. So we just find the area of this, then from we use definite integrals. So from this limit to this limit we find integrate, and then we find the area of the entire under the curve, any curve. So that's the basic principle of application of integration, or to find the area under a curve. Now what are the parts? Suppose this is a particular question. What are the important parts? That the first is you should be able to draw the given curve correctly. You should know what curve it is, how to draw it, what are the points. Then you have to see which area we have to find, and then the final thing, solving the integration. Now we will draw the given ellipse. This ellipse has major axis as x-axis because the term below x square is greater. So this is the ellipse. Now we want to find area of this entire ellipse. For that, as it is symmetric, we will just find the area under this one quadrant. And then we are just going to multiply by 4. Now what are these points? This is a comma 0. A square is 16. So it will be 4 comma 0. A is 4. And this is nothing but 0 comma 3. So anyway, we don't need both. So what we will do is, to find integration, the formula is to area under the curve. If you want to find area of this, let us say this is A1, this part. So for that, we integrate from 0, we take the limits of x coordinates. This is 0 to 4, y dx. Remember, this is the formula. So integrate a to b, what your limits are there, y dx. And the limits should be of x coordinates. So here it is 0 to 4 y dx. Now what is this y? Y is, you have to take it from that curve which is given. So you first write this in the form of y, substitute here and do the integration. So from this now, what will be y square? This will be y square. We'll take the square root and we will get y. So y will be 3 by 4 under root 16 minus x square. Okay, so whatever curve is given, you have to find y of that. Then we integrate y dx. We'll substitute y as this. We'll do the integration and then we'll substitute the limits. Okay, so we have substituted our y here. 3 by 4 constant I have taken out of integration. So integral 0 to 4 under root 16 minus x square dx. Now this is the identity. Of course, your all identities should be perfectly done, because you cannot go ahead if you don't know this identity. This is that lengthy identity. So under root a square minus x square is 1 by 2x into under root a square minus a square plus a square by 2 sine inverse x by a. So here a is 4. So x by 2 under root 16 minus x square plus 16 by 2 a square by 2 sine inverse x by a. And then we will substitute limits. 3 by 4 is there, so I put a bracket. It is for both the terms. So now first we will substitute. First I have simplified that 16 by 2 8, and now I can substitute first the upper limit 4 minus the lower limit. So substitute upper limit minus lower limit 0. So this term will become 0 only. Substitute upper limit, lower limit. Remember the point. Put proper bracket. This is upper limit minus the lower limit. So anyways, in this case, the second part will come 0 because sin inverse 0. This is also 0. This point, if we say again this term, first term is 0, 16 minus 16. So we just are left with one term, that is 8 sin inverse 4 by 4. So we get that is 8. So this term is 0, this term is 0. We get 8 means sin inverse 1, which is pi by 2. Sin inverse 1 is pi by 2. Pi. So area in the first quadrant of the ellipse, it is 3 pi square units. Now we have to multiply by 4. Don't forget the last step. We have just, because it is symmetric, we can just multiply by 4. So area under that ellipse or bounded by the ellipse is 4 into 3 pi. That is 12 pi square units. Next question, and very important one. Find area of region in the first quadrant enclosed by x-axis and the line y equal to x and the circle x square plus y square equal to 32. So as I told you, first part is we have to draw the correct diagram of circle and this line, and then just check what area we have to find it, and then the final part, integration and calculation. So this is the equation of circle part whose center is origin, x square plus y square equal to a square. Its center is origin and radius is root 32. Okay, so center 0, 0 of this circle, and we draw a circle whose radius is root 32. So 4 root 2. So this point on the x-axis, because this is the radius, will become 4 root 2, because a square is 32, root of 32 is 4 root 2. Then we want to find not just the circle, but they have given one line. Y equal to x is a line passing through the origin. So this is a line passing through origin, y equal to x. So we have to find the area in the first quadrant, which is bounded or enclosed by x-axis, means this. Then this line y equal to x and the circle, so this is the part that we have to find the area under the area enclosed. Now here one more important part is we have to find this point of intersection of the line and the circle. Now in the first question it was just an ellipse and we knew that point, only that thing, but here we should also find this point, that we can find at least x coordinate by solving this. So I will substitute y equal to x in the equation of the circle. So I get x square plus x square is 32, 2x square 32, x square is 16, x is 4. Because in first quadrant I am not taking minus 4. So this point will have x coordinate as 4. Of course, y coordinate will also be 4. So this is 4, 4 that you can just see. X is 4, so y will also be 4. Or even if we substitute here, we will get same. So that's the first. So we have done two parts. One is drawing according to the given thing, and then finding area which we have to find and the point of intersection. Now we have to find entire this area. So you cannot just take one thing. this actually composed of two parts. These are the two parts that you have to see. So I'll name this point, let us say A, and this point as B. So this is the first part and this is the second part. So we have to find the area of 1 and 2 and then add. Now area 1 is nothing but, see, by integration we are finding area under the curve. So this one part is nothing but if you find the area under the line. So that time we have to consider y of the line. Then the second part we have to consider area under the circle. So you have to find two different areas here. Area under the line, the first part, see. You cannot just take area under the line will not, that won't be covered. The part 2 won't be covered in area under the line. Area under line only will be this part and area under the circle is this. So that time when we consider area under the circle, we will have to find, we will have to take y of the circle. Okay, so area 1 will be equal to 0 to 4 y of line into dx, A1. Okay, now A2 is from here to here. See properly even the limits, from 4 to 4 root 2 y of circle into dx. So we are going to calculate this A1, A2 and then add, and that will give you the final answer. Okay, so this is our A1, area under the line. We have taken y as x because y equal to x is given the equation of the line. So 0 to 4 x dx. For the second part, we have to consider y of the circle. So that equation of the circle is x square plus y square equal to 32. From that we will get y as under root 32 minus x square into dx. So one by one we will first solve the integration. So this will be x square by 2. 0 to 4, that is 16 by 2 minus 0, so that is 8 square units. So that is A1. For A2, we again have that same formula which we have taken for the first question, that is under root a square minus x square is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. From the limits 4 to 4 root 2. So now it is substitute upper limit minus lower limit. So this I will substitute x as 4 root 2, that is upper limit, minus, now we have to substitute the lower limit, that is 4. You can see here this part, the first term will become 0, 32 minus 32. Here it will be 16 sine inverse 1 minus, this will be 2 root 16 plus 16 sine inverse 1 by root 2. Sine inverse 1 is pi by 2. Sine inverse 1 by root 2 is pi by 4. So after simplifying, you will get 8 pi minus 8 and this is minus 4 pi. So that means 4 pi minus 8. So this was area under 2. Area 1 we got 8. So total area or required area is, we will add. Answer is 4 pi square units. The next question is related very simple. This is a parabola y square equal to 9x. So you should know that there are 4 parabolas. Y square equal to 9x positive x-axis, symmetric about positive x-axis. Y square equal to minus 4ay. Okay, I'll just draw all these 4 parabolas. This is y square equal to 4ax. Because this is a must in application of integration, that you should know the proper curve. So this is y square equal to minus 4x. This is upwards, that is x square equal to 4ay. And this is x square equal to minus 4ay. So these are 4 parabolas with vertex 0. So we have y square equal to 9x. So this parabola, which is symmetric about positive x-axis. So first we'll draw the parabola which is symmetric about positive x-axis, y square equal to 9x. So if you compare this to the standard equation, y square equal to 4ax is the standard equation of a parabola. So where 4a will be equal to 9, so a equal to 9 by 4. So this is called as the focus 9 by 4 comma 0. Anyways, here they have given you x equal to 2 and x equal to 4. So right now we don't need the focus because we don't have to find. Sometimes they ask you if that between the lattice rectum you have to find parabola till lattice rectum, then that time we'll have to consider this focus. Right now they have given is x equal to 2 and x equal to 4. Between that only you have to find the area. So let us say this is x equal to 2. This is x equal to 4. So we have to find this area. So see the steps. First we draw it and then we show the area which we want. So this is the area that we have want. So area will be equal to, from the limits 2 to 4, y of the parabola, which is nothing but root 9x. So that is 3 root x dx. So root x, you find the integration. So 3 here will get cancelled. Get 2. Then you substitute upper limit minus the lower limit. So that will become 4 cube. 64 root, that is 8. 8 root is 2 root 2. So answer is 16 minus 4 root 2. The required area.